of information in this chapter. You have a mix today of looking at slope or derivatives and inverses, and you'll see how they kind of go together in the days ahead. I'm sorry about that. So let's just kind of get started. We want to find the slope of y equals e to the x at the point natural log 3, 3. So how is it that you're going to go about doing that? What does it mean to find the slope? Derivative. It means derivative. Good. So what we have to do is we're going to start this by finding its derivative. So right now, why don't you all go ahead and find the derivative? Y equals e to the x. Good. Okay, so if I want to know what it is at the point natural log 3, 3, what am I going to do? Plug it in. So that means I have e, and in the x, I'm going to put natural log 3. What about the y? Do I put that in for the y? No. Remember, this actually is y prime because we were talking about the derivative. So when we solve this, I'm finding the slope at that spot. So that y value really isn't important in terms of solving this question. So what happens with e and ln? Cancel out. My answer to this was 3. And so therefore the slope of this is 3. That would be my answer. Easy, right? All right. How about if I asked you instead to find the slope of x equals e to the y? A little bit different now, because your thought is to do the derivative, right? Here's the thing we need to know about slope, though. Think back to 9th grade, 8th grade, 7th grade for some of you. When you learned about slope the first time, what is slope? Rise over run, change in y over the change in x. If I write it in the form of calculus, okay, notation, it would be dy over dx. Some of you in science classes will know this as delta y or delta x. Does this all ring a bell? And so this is slope. What you may not realize is if I do the derivative of x equals e to the y, when you do the derivative of this, you're doing the derivative of x. Now this is some notation that you need to be aware of, with respect to y. And the way that it's written is dy. Dx to dy. When you find the slope of this, you're doing, because this says x equals, you're doing the derivative of x in respect to y. See the y on the right-hand side? And so it's still e to the y. Okay? And when you plug in the value for y, and we get the answer, let's just do that real quick. That would be e, and what is the y value here in this question? ln, 3. And we solve and we get 3. What you need to remember is this is not actually the slope, because slope is dy over dx. And the reason why I have always told you that the derivative is just, find the first derivative, that's how you find slope, is because every equation you have done up to this point has been y equals. Are you following me? But now what you're going to see is equations don't have to be set up in that form. And where we're headed with this is sometimes it is easier to solve for y and then figure out what the derivative is. And sometimes it is easier to just do it this way. And I'm going to show you how they actually do relate and how we could actually do this. So if I want this instead to say dy over dx, what's going to happen is instead of this being 3 over 1, it's going to be 1 over 3. Okay? Now let me just take a minute. You don't need to write this down, but this is just to prove it to you a little bit. Okay? If instead I said, all right, wait a minute, x equals e to the y, we've never done it with x equals. Mrs. Bass and I have no idea how to do that derivative. So what do? I'm like, I'm on my own. I'm going to solve for y. Can somebody tell me how you'd get rid of e? ln on both sides. So this would be y equals the natural log of x. Are we good? Now let's do the derivative. And let me point out to you, it's dy over dx. Do you remember this notation throughout the chapter? You've seen this. If I do the derivative, what's the derivative of natural log? Okay. And so now I'm going to plug in x. because it says 1 over x, right? And what is x? Isn't that amazing that they actually are the same thing? And so, believe it or not, you can do both methods, but there are times, in particular, inverse cosine, inverse sine, where you can't do the derivative of that. You don't know how to do the derivative of inverse cosine, inverse sine. So what are you going to do? Well, then there's going to be a method that we're going to learn in the coming days. How do you handle those? Can we put it back to the original, sine x or cosine x, and then flip it? And that's really what is happening. So, okay, let's try another one. Find the slope y equals x squared. I think that's supposed to say at 2, 4, and negative 2, 4. So why don't you guys go ahead and find the derivative. I want you to find the slope at 2, 4, and negative 2, 4. So hopefully you all were able to get that. Did anybody have any trouble with that? We're all good? Wonderful. Okay, no problems, right? Let's move on down the way here, and let's look at now x equals y squared. Now, once again, you can choose to solve for y and get the derivative of that and find what the slope is at the point 4, 2, and 4, negative 2. Or you can do the derivative as you see there, x equals y squared, and work with that. So give it a shot. Try it on your own, and I'm just going to explain it here in a minute, so I'll let you do it. Hold on just a second. I actually wanted you to look at the solution. So now you're looking at the solution of both methods. One being you solve for the derivative with the x equals, and one you solve for the y equals. The difference between the two that you're going to notice is the one on the left, you see that you have a positive 1/4 and you have a negative 1/4. The one thing that we have to remember is whenever you take the square root, you have to remember plus or minus. And so what really needed to be taken into account here is that that really is plus or minus in this question. And that even here, as you're looking at the square root, it's a plus or a minus. And so if you were to look at this parabola, you would recognize, oh, we've got x equals y squared. There's a part where your slope is positive, and there's a part where it's negative. And so you would observe which part of the graph we're looking at. So being mindful of what that graph looks like helps us. Do you follow? So you're looking at these 2 points and you'd say, oh, well, this one, because x equals y squared, would look like this. So 4, 2 would be up here, and so that slope of that would be positive. So that would be positive 1/4. However, here, do you see what I'm saying? Is going to be continuing to go down like this, right? Because your parabola kind of keeps opening up. So it would be a negative slope, even though it looks somewhat slight. Well, it is. It's 1/4, right? Would be, in fact, negative. So that distinction does need to be made, but it helps to know what the graph looks like to help you with that. All right. So it helps to actually understand inverses, obviously. And it helps us to remember inverses. So the only piece that's left that I want to just talk about, because I know it was way back in the day, back in pre-calculus, chapter like 5, so early in the year where you were doing inverses. My hope is that you know how to do these, and this is just kind of easy for you. So I just want to make sure that we all remember how to do inverses. Remember, inverses simply mean opposites, but one of the, does anybody remember how to solve for an inverse, Lauren? You switch the x and the y. So the first step for this, if somebody loves steps, is to start by step 1, set it equal to y. Step 2 is to do just as Lauren suggested. You're going to switch the x and the y around. And so if we're looking at this first example, it'd be y equals 3x. We'd switch the x and the y around. And then can anybody pick up from there? What happens after that? Jordan? Solve for y. You want to get y alone. So y is over here, so we want to move everything onto the other side. So how would I move that 3 in this case? Easily divide by 3, great. And so we'd have y equals x over 3. So the next one, what's the first thing that I'm going to do? Desi? Set it equal to y. Number 2, y equals x plus 3. Then what am I going to do, Rebecca Hunt? Switch the x and the y around. And then I've got to do what, Danielle? And how do I do that? Perfect. Subtract the 3. And so I get y equals x minus 3. This is easy, right? And so as part of your assignment tonight, you're going to notice that we'll solve for the y, and we'll actually be looking at this in more in-depth type equations, obviously. So let's just do one more. Let's skip down here and look at these more difficult ones, because I think the other ones are pretty easy for you. Are we okay with that, just for the sake of time? So e to the x plus 2. So first step for this, Julia, is to do what? Set it equal to y. So let's set this thing equal to y. Step number 2, Nikki. Switch the x and the y around. Whoops. Yeah, I did it right. Okay. E to the y plus 2. Good. Gianna, how do you get rid of that e? ln of both sides. Now, when you do the ln of both sides, you have the natural log of x, since x is the only thing over there, right? Equals, and you have y plus 2. And then what am I going to do, Eric? How do you get rid of this 2? Just subtract 2. And so here's a question for you, just to make sure we all follow this. Do the parentheses go around the x and the minus 2? No. This means the natural log of x, and then you subtract 2, right? Because the x was the only thing over there. Follow me? How would I have had to ask the question? What would I have had to do first if I wanted the natural log of x minus 2? What would I have had? It would have to be e to the e to the y, and then had the plus 2. So you'd have subtracted the 2 first. Good, Ryan. You'd have subtracted the 2 first and then done the ln, and that would have given me this. Very good. Very good. I don't want to be confused if somebody's looking at that. Okay. So obviously we need to be able to do inverses, and as you look through your homework tonight, part of it is to do some derivatives. And to remember that slope is the derivative of y over the derivative in respect to x, dx, dy dx, okay? And part of it is to do some inverses, which are pretty basic. Make sense? So I'd like for you to do tonight, or this weekend, or whenever, numbers 1 through 6, okay? And I think I'm going to at least teach normally in class on Monday as well, as we walk through these a little bit, and we'll just record the lessons.